This is a continuation of our earthwork discussion for this week. Talk a little bit more about excavations. We talked about trenches already and what is a trench. But an excavation is defined as any man-made cut, cavity, trench, or depression in the earth's surface created by earth removal. And a trench, of course, is just an excavation where the length is much greater diameter than either the width or the height of the particular excavation. I guess one of the questions we want to ask ourselves is, in light of heavy construction, why is it necessary to excavate material at a construction site? I think that's something that we should all know. However, the real reason is just to achieve a desired grade, or to make room for a structure or a subsurface structure that we want to put into place. For instance, we'll trench maybe to put in some type of a drainage structure, or we might excavate to build a foundation for a vertical structure, or for a bridge, or sometimes we'll want to excavate material because it's poor soil and we want to replace it with a more desirable type of material, or a select material, as the Department of Transportation would call it. Various types of excavation equipment, bulldozer, a wheelless front end loader, clamshell, which is used basically in water when you want to remove, for instance, gravel or shells from a shallow body of water. You can also see them using a clamshell type device when they're deepening, for instance, government cut where the cruise ships come in and out. They'll use a clamshell type device on a barge. We have a tracked excavator, and basically it just describes this as on the track rather than a wheel. As we have here, we have a wheeled loader. Here we have a tracked excavator. An elevating excavator, a backhoe loader, we have a backhoe and we have a loader there. It's a combination of the two. And a remote grader for smoothing out our nice grades to give us a cross slope that we might want on a roadway prior to putting in our base and our pavement itself. Excavation in groundwater. The water table is the normal level of groundwater. It's not constant, but it's pretty regularly, in particular South Florida, it's fairly stable. What are some problems we encounter if we have to excavate below the water table? Well, of course, as we excavate, we're going to be filling our excavation with water as the water level rises to the level of the water table. Then the next question is, of course, what do you do if you have to excavate below the water table? Well, we'll pump the excavation to empty it to keep it dry. May require a water barrier of some sort to keep water out. Dewatering system, continuous pumping around the periphery to keep the water table low. Cementitious stabilization of the subgrade, a fairly new process that is becoming more popular with vertical construction in South Florida. We would do a stabilization of that particular subgrade and stabilize it well below our excavation level and broader than our excavation dimensions, and so that we'll come back and remove it, and the hydrated material, the hydrated stabilized material, acts as a water barrier. That's how this particular material works. The excavated material is currently being reused on roadway projects here in South Florida. Types of excavation, well, there's general excavation and special excavation. And I guess the question is, what is the difference? Well, special excavation consists of removal of all the existing structures therein, defined herein: earth, excavation and borrow excavation, the placement of all suitable excavated materials in the subgrade or embankment or as a replacement. Calculating excavation volumes in tonnage. First example we'll use is we have a highly cohesive clay with an in-place density of 140 pounds per cubic foot. It's to be excavated in an urban area. The dimensions of the excavation are length 20 feet, width 30 feet, depth 10 feet. Before we go any further, would this be considered a trench? Well, clearly not, because its length does not far exceed the dimensions of the width or the depth. Matter of fact, in this case, the width of our excavation has a larger dimension than the length itself. So we have a depth of 10, width of 30, and a length of 20 feet. What is the volume of material to be removed? Well, we have here basically a rectangular type of excavation, so it's very easy to calculate by multiplying the length times the width times the height. In terms of cubic feet, divide that by our 27 cubic feet per cubic yard, and we come up with 222.22 bank cubic yards, and the weight would be 6,000 times 140 equals 840,000 pounds. Divide that by 2,000, that's pounds per ton, 420 pounds. Of course, our 6,000 would come from our calculation here of 6,000 cubic feet, because the density, or the in-place density, is 140 pounds per cubic foot. So we'll calculate this in terms of pounds and convert it to tons. So we'll always convert volume of excavations into cubic yards and weight of excavations into tons. In excavation, we've seen a similar formula to earlier in another lecture. It says calculating the excavation volumes and tonnage. The volume of the calculation for a sloped excavation on non-cohesive soils. The volume V is equal to H over 3, which is a height, times A plus B plus the square root of A times B, where A is the top area, B is the bottom area, and H would be the vertical height. And we know how to calculate this vertical height by using the Pythagorean theorem, of course. We have an excavation. Example number 2, a sandy soil with an in-place density of 120 pounds per cubic foot. It's to be excavated with a 1-to-2 slope on the sides. The dimensions of the excavation are length 20 feet, width 30 feet, depth 12 feet. What is the volume of material to be removed, and what is the height of the material to be removed? The volume is equal to the height divided by 3 times the top area plus the bottom area plus the square root of the top area times the bottom area. So our top area is 20 times 30. That's 60 square feet, and the bottom area is going to be 20 minus 12 over 2 times 2 times 30 minus 12 over 2 times 2 is equal to 8 times 18, 144 cubic feet. The volume, therefore, is 12 divided by 3 times 600 plus 144 plus the square root of 600 times 144 is equal to 4151.8 cubic feet, or 153.8 bank cubic yards. And the weight would be the volume in cubic feet times its density, and that would be 249.1 tons.